Welcome to PreMath. In this video, we have got this purple semicircle with a center O fully inscribed in a right triangle ABC, as you can see in this given diagram. And moreover, this point D is the point of tangency. And furthermore, this segment CD is 2 units, whereas this segment EC is 1 unit. And now our task is to calculate the area of this purple shaded semicircle. Please don't forget to give a thumbs up and subscribe. And please keep in mind that this figure may not be 100% true to the scale. Let's go ahead and get started. And now let's recall the two tangents theorem. According to this theorem, if two tangent segments are drawn to one circle from the same external point, then they are congruent, as you can see in this given diagram. And here we can see this segment AO is going to be equal to this segment BO. And now we are going to apply this two tangent theorem on this given problem. And here we can see this tangent AB is going to be equal to this tangent AD. If I label this tangent AB as x units, then our AD tangent is going to be x as well. And now let's make an observation. We can see this whole side length AC is going to be the sum of these two individual lengths x and 2. So that is going to give us x plus 2. And now we can see that this OB is the radius of this purple semicircle. So I'm going to label this one as lowercase r. Then this OE is going to be radius lowercase r as well. So therefore this whole side BC is going to be r plus 1. That is going to give us 2r plus 1. And now let's focus on this right triangle ABC, whose side lengths are x, 2r plus 1 and x plus 2. And we are going to apply the Pythagorean theorem on this triangle. And here's our Pythagorean theorem: a square plus b square equal to c square. And in our case, our hypotenuse is x plus 2, whereas our two other legs are x and 2r plus 1. Let's go ahead and fill in the blanks in this Pythagorean formula. So we are going to have x square plus 2r plus 1 whole square equals to x plus 2 whole square. And now let's recall this famous identity: a plus b whole square could be written as a square plus 2ab plus b square. We are going to apply this identity on these binomial, this binomial and this binomial as well. So therefore we are going to have x square plus that is going to give us 4r square plus 4 times r plus 1 is going to be equal to x square plus 4x plus 4. And now we can see this x square and this x square, they are gone. And now we are going to subtract 4 from both sides. This positive 4 and negative 4 are gone. So therefore I can write 4x is going to be equal to 4r square plus 4 times r minus 3. I'm going to label this one as our equation number 1. And here's our next step. I'm going to connect this center O with this point D, as you can see in this next step. And now we can see this OD is the radius of this purple semicircle. So I am going to label this radius as lowercase r as well. And now let's recall the circle theorem. According to this theorem, the angle between the radius and the tangent line will always be 90 degrees. So no wonder this angle has got to be 90 degrees, since this is our radius and this is our tangent line. And now let's assume alpha and beta are our two complementary angles. In other words, the sum of these two angles, alpha plus beta, must be equal to 90 degrees. Let's assume that this is our angle alpha. for this triangle ODC, if this angle is 90 degrees, then this angle has got to be our angle beta. And for this big right triangle ABC, if this angle is alpha, this angle is 90 degrees, then this angle has got to be our angle beta. So therefore we can see that this big right triangle ABC is similar to this smaller right triangle ODC according to angle-angle similarity theorem. So therefore we are going to have a proportion. So therefore we're going to have a ratio of AB and OD is going to be equal to the ratio of BC and DC. And now we can see our this side AB, this side is X. So I'm going to replace this AB with the X. And our this OD length is simply lowercase r. So I'm going to replace this one with the lowercase r. Our side length BC is this whole side length, which is 2r plus 1. So I'm going to write down 2r plus 1 over here. And finally, this segment DC is 2 units. So I'm going to replace that one with 2 units. Let's go ahead and cross multiply. So therefore, we are going to have 2 times x equal to 2r square plus r. And now let's focus on this equation 1. We got 4x on the left hand side. And for this equation, we got 2x on the left hand side. So I'm going to multiply this one by 2. So therefore, I'm going to multiply by 2 across the board. So therefore, we are going to get 2 times 2x is going to give us 4x equal to 4r square plus 2 times r. I'm going to label this one as our equation number 2. So thus we are ended up with these two equations, equation 1 and equation 2. And we are going to compare these two equations. And now we can see our left hand sides are identical. So therefore we are going to equate the right hand sides as well. So therefore I can write 4r square plus 4 times r minus 3 is going to be equal to 4r square plus 2 times r. And now we can see this 4r square and this 4r square, they are gone. So therefore we are ended up with 4r minus 3 equals to 2r. And now I'm going to move this negative 3 on the right hand side, and at the very same time I'm going to move this 2r in the opposite direction. So therefore we can write 4r minus 2r equals to positive 3. On the left hand side, that is going to give us 2 times r equals to 3. Let's divide both sides by 2 to isolate r. This 2 and 2 is gone. So therefore our radius lowercase r turns out to be 3 divided by 2 units. So thus our radius r turns out to be 3 divided by 2. And here's our final step. Now we are going to calculate the area of this semicircle. And now let's recall the area of a circle formula. Area equals to pi r square, where r is the radius. So therefore, since we are dealing with this semicircle, so the area of the semicircle is going to be this area pi r square, and we are going to divide it by 2. So therefore, the area of this purple semicircle is going to be equal to pi divided by 2 times our radius is 3 divided by 2. So I'm going to write down 3 divided by 2 whole square. And now we can see 3 divided by 2 whole square is going to give us 9 divided by 4. So therefore we can write pi divided by 2 times 9 divided by 4. And that is going to be equal to 9 pi divided by 8 square units. So thus after all the calculations and manipulations, the semicircle area turns out to be 9 pi divided by 8 square units. And that is going to be approximately equal to 3.53 square units as well. And that's our final answer. Thanks for watching, and please don't forget to subscribe to my channel for more exciting videos. Bye.